Hello, my name is Steve Bowler, and in this video we're going to be taking a look at OSPF. In particular, with OSPF, we're going to be taking a look at filtering networks with OSPF using distribute lists and filter lists. So what we're going to do in this lab is we're going to configure both distribute lists and filter lists. We're going to go ahead and do some debug commands and some show commands for verification that we have completed our tasks correctly. I'm also going to show you the difference in OSPF between filtering using a distribute list and a filter list. It is very important to understand how these two commands are filtering, or not commands, how these two types of filtering are implemented in OSPF and what they actually filter. So as you can see here in our lab, we have 6 routers. Router 1 and router 2 are connected via serial 00 in area 0. Router 1, 3, and 5 are connected to form area 135. Router 1 to 3 is using Fast Ethernet 00, and router 3 and router 5 are connected using serial 00. On router 2, 4, and 6 are in area 246, and router 2 and router 4 are connected via Fast Ethernet 00, and router 4 and router 6 are connected via Fast Ethernet 00. I'll also go ahead and expand our drawing here, our topology summary, so you can see which links are connected to which. And so as you can see here, we have 3 areas: area 135, area 0, and area 246. So what I'm going to do now is I'm going to pause the lab. I'm going to get the baseline configuration set up on all the routers. Then we'll go ahead, we'll enable OSPF, and we'll go ahead and take a look at filtering OSPF using distribute lists and filter lists, and we'll also take a look at what the difference is with these two commands, our forms of filtering within OSPF, and then we'll also do some show commands, maybe some debugs to verify our results. Okay, so we're done with the baseline config. What I did was I went in and all the IP addresses here, you can see I have configured on all the interfaces. Also, I added a couple more loopbacks. So router 5 has 2 loopbacks, loopback 0 and loopback 55. Loopback 0 is 5.5.5.5/24, and loopback 55 is all 55/24. Router 6, I have 2 loopbacks. Loopback 0 is 6.6.6.6/24, and loopback 66 is going to be all 66.66.66.0/24. So what we're going to do is we're going to advertise these networks into OSPF, and then we're just going to take a look at the behavior, doing filtering here using distribute lists and filter lists. So what we're going to do now, we're going to go ahead and set up OSPF. First off, I guess I should tell you here of all the networks we have going on. We're going to be using the Class B private network range of 172.16, and between router 1 and 2 we're going to be using the 12 network. Between router 1 and 3 we're using the 13 network. Between router 5 and 3 we're using the 35 network. Between router 2 and 4 we are using the 24 network, and between router 4 and 6 we are using the 46 network. So let's go ahead and get OSPF configured here. On router 1 we will configure OSPF process 1 on all the routers. So router OSPF 1, we're going to go ahead and advertise our networks into OSPF, and then we'll just do a simple ping from end to end here, from router 5's loopback 0 to router 6's loopback 0, just to make sure that we have full IP reachability across our OSPF domain. So in OSPF on router 1, we're going to advertise network 172.16.12.1 with the host mask of all zeros. And we're going to advertise that into area 0. Then we're going to advertise network 172.16.13.1, and that is going to be going to router 3, and we're going to advertise that into area 135. Okay, so router 1 is done. Let's go into router 2. Router OSPF 1. We'll advertise network 172.16.12.2. Again, we're using the host mask on all of our network commands, and that's going to advertise just this IP address. Whatever interface has this IP address on it, it's going to start sending OSPF hellos and try to form adjacencies on. Again, this is going to be in area 0 because that's connecting to router 1. And then we're going to be also advertising network 172.16.24.2. That's going to be connecting to router 4 in area 246. So we'll specify area 246 here. As you can see, we have a OSPF neighbor adjacency message that came up in the log showing us that we have a adjacency now with router 1. But we're going to verify neighbor adjacencies later. We'll just make sure that we have full reachability here first. Let's get all of our routers configured with OSPF. So router 3, we'll do router OSPF 1. Then we're going to advertise network 172.16.13.3 into area 135. Then we'll also advertise network 172.16.35.3 into the same area, 135. And as you can see, we have a neighbor adjacency now with router 1. Okay, now let's go to router 4. And get it configured. So we'll do router OSPF 1. For OSPF 1, we're going to do advertise network 172.16.24.4. And we will do that in area 246. Also, network 172.16.46.4. We'll advertise that into area 246 as well. So we should have had a neighbor adjacency come up with router 2 already. If I do a show IP interface brief on router 4, let's see if we can ping router 2, 172.16.24.2. And it looks like we don't have reachability yet. So let's go to router 2 here. If I do a show IP interface brief on router 2, as you can see here, the reason why our neighbor adjacency didn't come up is because our interface is admin down on router 2 for fast Ethernet 00. That's a connection to router 4. Let's go into there and do a no shut, and what we should see here is a neighbor adjacency should come up here any second. So now the interface is up, so now layer 3 should be able to converge, and it does. So now router 4 is adjacent to router 2 in area 246. So let's go on to the next area here, or the next router I should say, router 5. We'll do router OSPF 1, and we'll do network 172.16.35.5, and that's going to be in area 135. Also, we're going to advertise router 5's loopback 0 and 55 addresses into OSPF. So we'll do the command network 5.5.5.5, and then we'll advertise that into area 135. Also, we'll do the command network 55.55.55 into area 135 here. And as you can see, we have a OSPF adjacency change here with router 3. Now we're neighbors with router 3. And the last router, let's go into router 6 and get it configured for OSPF. And then we will take a look at filtering. So router OSPF 1, do network 172.16.46.6. Again, this is our connection to router 4 in area 246. So we should see the adjacency change. And there we have it. So now let's advertise our loopbacks into area 246. We'll do that by doing network 172.16. I'm sorry. We'll do network 6.6.6.6. We'll advertise that into area 246. And then we will also put our 66 network as well into area 246. Okay, so that should be it. Now what I should be able to do on router 6, if everything is working correctly, should be able to do show IP route, and I should see the inter-area routes. Okay, I should see the LSA type 3s coming in from area 135. So these routes from router 5, these networks should be being propagated into area 135, into area 0, and then into area 246. And as you can see here, we are now seeing those networks. So let's go to router 5 and see if we can see those networks on router 6. If I do a show IP route, as you can see, I see from router 5's point of view, I do see 2 networks, but they're coming in as /32s, and that's because we have to go back to router 6, change the network type on the loopback interfaces. So if I do a show IP OSPF interface, loopback 0, you can see here that it is being advertised, even though our network mask, our subnet is 20/24. With the network type of loopback, there's going to be a /32 advertised. So let's go ahead and change this default behavior. We'll do IP OSPF network, and then we'll just do point to point. So we'll go into loopback 66. We'll do IP OSPF network point to point as well. So now on router 5, if I do a show IP route, let's give it a second here. It looks like one of the networks has converged to a /24. Let's do it again here. It might take a second. And now you see our 2 networks that we're learning from router 6 have converged. So now we're learning them as both as /24s. So let's go back to router 6 and see if we see the same behavior on router 6 for the routes that we're learning from router 5. As you can see on router 6, we're only seeing 1 network from router 5, which is the 55. So there might be something wrong within router 5's OSPF configuration. Let's just do a show IP protocols on router 5. Let's do a show IP interface brief on router 5. And the problem here is that we have the network command for the 5 network. However, we never created a loopback 0. So the router does not have the 5 network attached to it. So let's go ahead and put in that network. Alright, so that should be it. So now that if we do a show IP interface brief, we now see that we have a loopback 0 interface with the 5 network on it, which we should have. Let's go to router 6 now and see if we can see those routes. And as you can see now, I can see the network, the 5 network. But as you can see here, we're still seeing them as /32s. Let's go ahead and change this default behavior of OSPF. We're going to go under the loopback interfaces and change the OSPF network type. So IP OSPF network, and then we're just going to do point to point, then interface loopback 55, and we'll do the same thing here. So now if I do a show IP route on router 6, as you can see, I am still seeing this as a /32, but I'm seeing the 5 network now as a /24. Let's give it a second. Let's give time for OSPF to propagate through all of our areas. And as you can see now, we are learning the route as a /24 for the 55 network, and for the 5 network, we're seeing it as a /24 as well. So let's go ahead and ping across here. Source it from our loopback 0, which is, we could just put in the loopback 0 here. And as you can see here, I do have reachability. So we have configured our OSPF network end-to-end now, and so now we're going to start doing some filtering, and I'm going to show you some key features in filtering OSPF using both distribute lists and filter lists. So in our first example here, what we're going to do is we're going to use the distribute list inbound, and we're going to filter the 6 network on router 6 on router 3, and we're going to take a look at the default behavior in doing so. So if we go on to router 3, what we're going to do is we're just going to create a very simple ACL. We'll just call it access list 6 to annotate the 6 network. Then we will do a deny. So we're going to deny the /6 network here, and then also under access list 6, what we're going to do is permit any. Again, because if we were to not do this command here at the end, the permit, all ACLs by default have an implicit deny all at the end of them, so all traffic would pretty much be denied with this ACL. So we got to make sure that we permit the rest of the traffic. So we're filtering just the 6 network from entering router 3. However, all the other traffic is going to be able to go through. Okay, again, now what we're going to be doing here is we're going to be using the distribute list, and we're going to do this inbound on router 3. And we're going to take a look at the default behavior in doing so. So in other routing protocols, you would think, okay, if I'm doing a distribute list inbound, say RIP, if we did this, then it would filter this route on router 3, and then it would also filter this route, the 6 network, propagating to router 5. So let's go ahead and take a look at how this works within OSPF and how it makes OSPF different than other routing protocols. So let's do router OSPF1, and then we'll put in the command here. We're going to use the distribute list command. So we'll do a distribute list, then the number here, so distribute list 6, and then in, and then it's going to ask us for the interface in which we're going to be filtering. And we're learning the 6 network via router 6. So our path here is 6, 4, 2, 1, then 3. So what we're going to do is we're going to be just applying this distribute list inbound on our fast Ethernet 00 interface. So now if I do a show IP route on router 3, you can see here that we have successfully filtered the 6 network from entering router 3's routing table. But if I do a show IP OSPF database, you can see that I'm still seeing the LSA type 3 in router 3's OSPF database. So now let's go ahead and take a look at router 5 and see if that network is now being filtered on router 5. If I do a show IP route now on router 5, what we can see is that we are still seeing the 6 network in router 5's routing table. And this is because, and this is a very key point here to remember, is that when we have a distribute list applied on one of our routers, in this instance we're doing it on area 135 on router 3, we have an inbound distribute list on router 3 in OSPF that's denying the 6 network. However, our OSPF database is still going to propagate this LSA type 3 throughout the area. And that is why router 5 is still seeing this network in its database. So a key point to remember here is when you're doing filtering using distribute lists with OSPF is that it's only going to affect the local router and no other router within the area. And we can see that here because router 3, if we do a show IP route, router 3 does not see the 6 network. It sees the 66 network, but it doesn't have a route to the 6 network. And that's because when working with distribute lists with OSPF, when we're filtering, it's only going to apply to the local router. The LSA type 3 associated with this network, which is the 6 network coming from area 246 inter-area route here, is still going to be propagated throughout the OSPF area, which is area 135 in this case. So although we're denying this route coming into router 3 in area 135, router 3 is going to still advertise LSA type 3 for the 6 network throughout area 135, and that is evident by going to router 5 and doing a show IP route, and we still see the 6 network in router 5's database, our routing table. We can still ping it too, so if we do a ping 6.6.6.6, we source it from our loopback 0. Actually, let's go ahead and do this real fast. We're seeing undeliverable here. Let's do this. And the reason we're seeing undeliverables here is because even though router 5 has the path to router 6 and it's seeing the network, the LSA type 3 coming from router 3, well, how does router 5 get to the 6 network? Well, it has to go through router 3. So if we go ahead and do a ping here on router 5 to the 6 network, and we go ahead and do on router 3, if we do a debug IP packet, what we can see on router 3 is that we are getting packets coming in from the source of router 5, that's the outgoing interface when we're doing these pings on router 5, going to destination 6.6.6.6, and then we're seeing unroutable here in the when we do the debug IP packet on router 3. That's because router 3 doesn't know the path to get to the 6 network. So as you can see here, this is going to cause a lot of problems, because right now, especially in troubleshooting, as you can see, router 5 looks like it knows how to get to the 6 network. However, this router that's in the middle of area 135, which is router 3, has no idea how to get to the 6 network. And that's because one of the key things with this implementing distribute lists with OSPF is what we saw here when we did distribute list inbound on router 3, blocking the 6 network. It's only going to block that network from entering router 3's routing table. It's still passing LSA type 3 for this network to router 5, as we could see here in our database. So router 5 is routing it to router 3, however, router 3 is dropping this traffic and sending undeliverables back to router 5. So in our next example here, what I'm going to show you is how to filter using what's called a filter list. And what we're going to do is we're going to apply this filter list, and all filter lists, for reference in OSPF, filter list has to be applied on the ABR. And in this case, we all know that an ABR connects area 0 to another area. So router 1 is an ABR and router 2 is an ABR. We can check on this if we go to router 2, and if we just do the command show IP protocols here under OSPF, we get the message that this router is an area border router. So very important here, filter lists can only be applied on the ABR correctly. And what this filter list is going to allow us to do is we're going to apply this filter list on router 2. What we're going to do in this example is we're going to filter the 55 network from entering area 246. So let's go on to router 2. What we're going to do is create a prefix list in this example instead of an ACL. With the distribute list, we're going to create a prefix list and apply it to the filter list. So let's go on router 2 first. Let's create the prefix list here. So we're going to do IP prefix list. We'll just call it deny loopback 60. I'm sorry. Deny the loopback 55. Deny loopback 55. So we know here that we are denying loopback 55 from on router 5. We'll follow that up with the deny statement, deny, and then it's going to ask us for the network. So it's going to be 55.55.55.0/24. And again, must be noted here that prefix lists are like ACLs in the fact that if there isn't a implicit, there is an implicit deny any at the end of the prefix list. So what we need to do here is go ahead and put in a permit statement that's going to allow all other networks in. So we're going to do that by doing the IP prefix list deny loopback 55, and then we'll just do a permit statement here. We're going to do permit 0.0.0.0/0, and then we'll do less than or equal to 32. So this type of prefix list entry is going to match anything. It's pretty much like a default route. So it's going to allow all networks of all network sizes are subnets allowed in from the 0 to 32. So before we do this, let's verify again on router 6 and router 4. First, let's go to router 4. We'll do a show IP route on router 4. As you can see, we're learning the 55 network and the 5 network. Let's just do a ping to the 55 network. As you can see, we are successful. Let's go to router 6. And we'll do a ping. Let's do a show IP route here. Make sure we have the 55 and the 5 network here. As we can see, we do. Let's go ahead and ping these networks. On router 4 again, let's ping the 5 network. As you can see, router 4 has reachability to both the 5 and the 55 network. And router 6 here also has connectivity to the 5 network and the 55 network. Okay, so let's now go back to router 2 and finish our filter list implementation. So we'll go to router 2. Again, filter list, like distribute list, we're going to apply that under the router configuration mode for OSPF on process 1 here. And the command for this is going to be using the area, and then we're going to specify the area here. So the area in which we're filtering into, which is going to be 246. So area 246, and then you can see here we have a lot of different options, a lot we've gone over in the previous labs. What we're going to do here is use the area filter list command. As you can see here, this is going to allow us to filter networks between OSPF areas. So area 246, filter list, and then of course the only option we have here is to apply a prefix list to the filter list. That's why we went ahead and created our prefix list here, which is deny loopback 55. So area 246 filter list, and then we're going to put in the name of the prefix list. I'm sorry, before we do that we have to type in prefix, and then we drop in the name of the prefix list, and we're going to be doing this we're going to be filtering these routes in to area 246. Okay, so now that we've done that, let's go ahead and go to router 6. We'll go to router 4 first. We'll do a show IP route. And as you can see here now, we do not have the 55 network in our routing table. On router 6, let's look at it as well. If I do a show IP route on router 6, and as you can see here as well, we do not see the 55 network as well. We only see the 5 network. So if I do a show IP OSPF database, also we don't even see LSA type 3 for the 55 network. Whereas before, when we were doing this distribute list inbound on router 3 in area 135, we still saw on router 5, which is in area 135, if I do a show IP OSPF database, we still saw the 6 network coming in. Even though we were filtering it on router 3, we were still seeing LSA type 3 in router 5's OSPF database. Whereas when we're using a filter list, what we have just witnessed is that when applying a filter list here, the network in which we are filtering, which is the 55 network on router 5 in area 135, which comes in as LSA type 3 to router 2, it's going to filter this LSA completely out to area 246. So we can see that because router 4, if we do a show IP OSPF database, you can see that we are not seeing LSA type 3 now for the 55 network. If we go to router 6, again, we don't see LSA type 3 for the 55 network here as well. So this is a successful implementation of a filter list. Again, we can compare both types of filtering within OSPF, where distribute lists will filter the network only on the local router when we're doing it inbound. However, it's still going to pass LSA type 3 along to neighboring routers down the line. So to router 5, as we saw in area 135, it was still seeing LSA type 3 for the 6 network, even though it's being filtered on the local router only. And with filter lists, what we saw is that when we filtered loopback 55 from router 5 in area 135, we were able to filter it from entering area 246 altogether. And we looked at the show commands, we looked at the databases, the OSPF databases on router 4 and 6, and we could not see the 55 network in them at all. And that's because with filter lists, it's going to filter LSA type 3. So if we look on router 2, if I do a show IP OSPF database, we can still see in area 0, we're still seeing the 55 network being advertised in the OSPF database. So on router 2, we still should see it having a route to the 55 network, which we do. And we still should have reachability. Because router 2, what we have to remember is it is in 2 different areas. It's in area 246 and area 0. And we only filtered the 55 network from entering into area 246 and not area 0. So let's go ahead and see if I can break this configuration real fast. We're going to shut down the interface from router 2 out to area 246. What I'm going to do is a debug IP OSPF. Let's do events and debug IP OSPF packet. Maybe debug IP OSPF rib. Then what we'll do is we will go and do an interface fast Ethernet 00, and we'll do a no shut here. We can see a whole lot of information here. Let's go ahead and clear all of that and see if, well, let's see. A lot of information here. Let's see if we see anything for 246. And as we can see here, might be able to find something. Looks like we have a lot of information here of all the routes that are being added into the OSPF rib. Also, we're seeing some neighbor elections for the DR BDR occur. What I was looking for here in these debug commands was maybe where it shows something about the filter list that we have implemented on router 2 that's filtering out the 55 network from outbound going to router 4 in area 246. Let's try one more debug here. Let's try the debug IP routing. Okay, let's go ahead and go back here and do a no shut on router 2's fast Ethernet 00. As you can see, our OSPF adjacency change with router 4. Doesn't look like we're able to catch that information doing the debug IP routing. Actually, let's see here. We are adding the 66 networks and the 6 network from router 6. However, if I do a show IP route on router 2, it is not showing us the filtering that's taking place here with the filter list. So, but it is very important that we understand how filtering was occurring with the filter list in area 246. What we did again is we set up on the ABR is where the filter list has to be implemented. So we went onto router 2, which connects area 0 to 246, and in this situation what we were doing was filtering loopback 55 on router 5 from entering into area 246. And we did this by going under router 2, we created a prefix list to deny the 55 network, and then also our second sequence in that prefix list was to allow everything. And then we applied the prefix list here into our OSPF configuration. We did that by going under OSPF process 1, and we used the area command. So we put in area 246. We followed that up with the filter list option, and then we followed that up with prefix, and then we followed that up with the name of our prefix list was to deny loopback 55, and then inbound. So what this command is doing is saying, okay, all routes that match the prefix list here, basically we're just doing filtering on this prefix list, and in this case we're denying loopback 55. So what this is saying is for anything going into area inbound into area 246, we're going to apply the prefix list. And in doing so with the filter lists within OSPF, this is going to deny LSA type 3s into the area. And that's what we saw here on router 4. We do a show IP route, we don't see the 55 network. If we do a show IP OSPF database, we don't see LSA type 3 455 network. And we also looked at router 6. If we do a show IP route on router 6, you can see that we do not see the 55 network in router 6's routing table. And also, if we do a show IP OSPF database, we do not see LSA type 3 for the 55 network in router 6's database, OSPF database. And in our first implementation, we used distribute lists. We filtered inbound. We filtered the 6 network on router 6 in area 246. We filtered that inbound on router 3 using a distribute list, and we tied the distribute list in on router 3 with an ACL. If I do a show run pipe to begin OSPF on router 3, what we can see here is we can see that we created an ACL which denied the 6 network, and then it permitted everything else. Then we went under the router OSPF1 process. We used the distribute list command. We called ACL6 with the distribute list 6, and then we're doing this inbound on fast Ethernet 00 because that's how we're learning of the 6 network through router 1's fast Ethernet 0s, or I'm sorry, through router 1, in which we're connected to via our fast Ethernet 00. And then we saw here with distribute list with filtering in OSPF is that LSA type 3 is only going to be filtered on the local router only. So if I do a show IP route on router 3, you can see here that we are not learning the 6 network on router 3. However, if we go to router 5 and do a show IP route, what we can see here is that we are learning the 6 network, and that's because on router 5, if I do a show IP OSPF database, you can see that LSA type 3 is still making it into router 5's OSPF database, and that's because it's on router 3's database, in router 3's database as well. And then we also looked at what kind of problems this can cause by using distribute lists within the area, because it actually looks like router 5 has connectivity or can reach the 6 network, but then we tested that by doing a ping, and we got undeliverables back from router 3, and that's because router 3 does not know how to get to the 6 network because of the distribute list inbound that we have going on here. Then also here, what we want to do on router 4 and router 6, we filtered the 55 network from coming in to area 246. Let's just ping the 5 network just to verify that we still have access to the 5 network in area 246. So on router 6, if we ping the 5 network, we still have connectivity. However, of course, if I try to ping the 55 network, we are getting timeouts. Okay, so that's it. So that's our OSPF lab here, where I showed you how to filter using both distribute lists and filter lists within OSPF. So I hope you guys have enjoyed this video, and I'd like to thank you for watching.